Okay, here's some functions operations or operations with functions, and they're pretty straightforward. Remember, a function is just a single valued set of ordered pairs, and in a lot of cases we can determine what the y value is given an x and putting it into a rule. And lots of times we write these in this way: f of x equals x plus 1. So when x is 1, y is 2. Or when the domain element is 1, the range element is 2. So 1 is paired with 2. So this is a rule, it would be a plus 1. And whatever we put in here for x, we just add 1. So if x is 3, f of x is 3 plus 1 or 4. And this is another function, g of x, and this g rule says x squared plus x. So whatever is in here, we square it and we add its value. So if this was 2, this would be 2 squared plus 2. Or 4 plus 2 or 6. So 2 would be paired with 6. So if we want to add functions, it's pretty easy. If we see f plus g of x, that just means f of x plus g of x. And if we've got our rules, we just add the rules. So we could simplify it like that, or we could find the values and add them. In this case, we have the rule, so f of x is x plus 1, and g of x is x squared plus x. So if I want to find f of g of x, I just add f of x and g of x. So I get x squared, x plus x is 2x plus 1. So we just add them. F minus g of x, that's just f of x minus g of x. Well, the x rule was x plus 1 and the g rule was x squared minus x. So I'll just take the x plus 1 rule minus the x squared plus x rule and simplify that. So I've got x plus 1 minus x squared, and a minus times a plus is a minus x. And notice that x minus x is 0, so we just end up with 1 minus x squared. Oops, excuse me. All right. So again, x minus x is 0, so we end up with just 1 minus x squared. So that's f minus g of x. So it's not too difficult. Looks far more complicated than it is. Here we have f times g of x. Well, that's just f of x times g of x. Now my f of x was x plus 1, and my g of x was x squared plus x. So I just have to multiply these, and I can just use the FOIL process. That's going to equal, well, x times x is x cubed. X times x squared is x cubed. X times x is x squared. 1 times x squared is just x squared, and then 1 times x is just x. And we could simplify that to be x cubed plus 2x squared plus x. And that would be f times g of x. You can see that. So we can just multiply them. X cubed, x squared, x squared, x. X squared plus x squared is 2x squared. So this is your f times g of x. And then f divided by g of x, that would just be f of x divided by g of x, which would just be f of x, which is x plus 1 divided by x squared plus x. Now we could simplify that. Just notice that we could do that. But if we leave it like this is fine. We just have to make sure that we take care of any restrictions on the domain. And that means that the denominator cannot be 0. We can't have 0 in the denominator, so x squared plus x cannot equal 0. Now we could factor an x out, and this is the same thing as x times x plus 1 cannot equal 0. That means x cannot equal 0 and x plus 1 cannot equal 0. So if I subtracted 1 from both sides, x cannot equal negative 1. So the restrictions on the domain would be that x cannot equal 0 or negative 1. Sometimes we put a parenthesis around the restrictions on the domain. In other words, if x is 0, 0 plus 0 is 0, and we have 0 in the denominator, that's a no-no. And if x is negative 1, well, negative 1 squared is 1, plus negative 1 is 0, we'd have 0 in the denominator. Now we could simplify this as long as we have these restrictions on the domain. If we have these restrictions, we could say this is the same thing as just 1 over x, because this is the same thing as x times x plus 1. So we could simplify it, or we could just leave it like that. So that's just some simple operations with functions. Addition, subtraction, multiplication, division of functions.